Hi, and welcome to the Structure 101 tour. This will be a series of short demos to give you an overview of the key functional areas in the Structure 101 product. In this first section, I'll show you how Structure 101 gives you a visualization of the implicit design of your code. So I've opened up the product and pointed it at the code base for Structure 101 itself, and I've switched to the composition perspective. In the viewer top left, I see a tree denoting the hierarchy of design items for this codebase, and the main viewer top right shows me the dependency graph for the item currently selected in that tree. Because I'm currently at the root, what I'm seeing here is in effect the set of top-level components in this codebase and a set of interactions or relationships between them. I can also drill down to get subsystem views of the code. For example, let's have a closer look at how the foundation area is composed. And I could keep going down, for instance, to see the classes within a package, or even the methods and fields within a class. The numbers on the arrows indicate weight of dependency. For example, this dependency has a weight of 3 because there are exactly 3 code-level references flowing across from the class MetaStructureBuilder to the class FlatStructureBuilder. I can see this in the dependency breakout viewer bottom right. Similarly, if I go back up to the root, I can see that foundation depends on util with a weight of 399. And this list in the dependency breakout viewer will show me those 399 individual code level references. Now, wherever I have these larger volumes of data to deal with, by the way, it usually makes sense to switch on these tree views in the dependency breakout to get a better sense of the distribution on either side of the dependency. But the important thing to understand here is that the Structure 101 models and visualization are inferred directly from how the code is right now. Now, if you've ever worked with externally maintained models of code-based design, typically in UML, either formally or whiteboard, you'll understand a distinction here. So, for example, a dependency arrow in an external model can have quite variable semantics. It could mean will depend on, or should depend on, or quite often used to depend on, and we haven't updated the design docs yet. And whenever I'm talking about this, I'll generally distinguish by saying that external models convey notional design, while Structure 101 shows you the implicit design, how things really are right now. And so looking at this model, there is quite simply no argument. Foundation really does depend on util, at least at the moment. That said, there is one major variable in Structure 101 models, namely the hierarchy, and it's very important to understand this to get the most out of the product. Now, Structure 101 is really based on the principle that particularly the higher level items in the hierarchy correspond to meaningful design items, components, subcomponents within a codebase, if you like. Now, by default, Structure 101 for Java uses the logical package hierarchy, but in some cases you may want to manipulate this to reflect different practices. And the way to do this is using transformations. Let me give you 2 quick examples. First, in the Structure 101 codebase, we have some legacy tests mixed in with the production code. By using this transformation on the screen now, I can take all of those test classes out based on a naming scheme and put them in a separate branch of the hierarchy. Second, and this one's quite common in the Java space, is to work with the jar first, package second view of the code rather than package first. I can do this using the jar transformation. Now, to finish, I'd like to take a quick look at a different codebase, just to illustrate some of the useful information we can get from visualization of implicit design. So the codebase in question, by the way, is FindBugs, and we're looking at quite an early version here, 0.87. And what we see here is a nice, well-defined component structure. Just one interesting notable is the I/O package is disconnected from the rest, so that's very probably dead code and would warrant a closer look. Let's switch to version 0.88, that came out just a month later. And the interesting detail here is that there's a back dependency from BA to controller, which is confusing the component structure. It's making controller and BA mutually dependent. Now, I think it's reasonable to assume this is a rogue dependency, undesirable. And there's just 2 code level references involved at the moment, so it would have been, I think, pretty easy to reverse this out had it been spotted. In fact, though, if we fast forward to version 1.10, we see that back dependency has in fact become entrenched. The weight has gone up to 73, and also that the confusion around components has spread to other areas of the codebase. But of course, in the absence of a shared vision of the codebase design and structure, this is probably quite a common phenomenon as teams evolve and change. And I'll finish with a recent release of FindBugs, version 135, and well, I'll leave you to draw your own conclusions.